So the lesson today is on molarity and molality. These are the two ways that we need to be able to express concentrations of a solution. So molarity, as you see here, has a symbol, a capital M. These are called molar solutions in the problems. The formula for molarity is that the molarity is equal to the number of moles of your solute divided by the number of liters in the entire solution. Now remember that a solution is the solute plus the solvent. So that's the entire solution. The solute is the substance that got dissolved in the solution. The solvent is the substance that does the dissolving. So let's look at a couple of examples here. So this says 20 grams of sodium hydroxide is dissolved in 1 liter of solution. So the sodium hydroxide is the solute, and it's 1 liter of solution. It wants us to calculate the molarity of the solution. So this wants us to find molarity, which is symbolized by a capital M. Now remember, the solute has to be in moles. So the formula is what you want to write down first. Molarity is equal to moles of the solute. In this case, moles of sodium hydroxide divided by liters of the solution. Now we know the liters of solution, so we can go ahead and plug that in here. We know it's a 1.00 liter solution. But we only have grams of the solute right now. So what we need to do is do a little conversion first. We need to convert 20 grams of sodium hydroxide to moles. So what we need is the molar mass. If you add up the molar mass of sodium hydroxide, 22.99 plus 16.00 plus 1.01, for the sodium hydroxide you get 40.00 grams per mole. This lets your grams divide out. So when you divide here, you'll get 0.500 moles of sodium hydroxide, and that's to 3 significant figures because 3 sig figs are our least. So now this number here can plug in to the numerator of our formula where moles of solute goes. So that's going to be 0.500 moles divided by 1.00 liters, which gives us for our molarity 0.500 molar. That will be your answer. You sometimes see this expressed as a unit as moles per liter. So you could write it as 0.500 moles per liter as the unit. So that's our first example. Right, let's look at example 2 in the notes. This question says, what is the molarity of a 3.5 liter solution that contains 90 grams of sodium chloride? So again, the molarity formula is moles of solute divided by liters of solution. Again, we know the volume of our solution is 3.5 liters, so we can go ahead and plug that into the denominator, 3.5 liters. But as in the last problem, they gave us grams of solute, so we need to convert 90.0 grams of sodium chloride to moles of sodium chloride. So you need the molar mass of sodium chloride here. That is 58.44 grams per mole. Now, of course, take the time to add that up yourself. Don't just take my word for it, but you need to make sure you know how to find the molar mass, and that's something you certainly should know how to do at this point, as long as we've been doing that. That gives us 1.54 moles. So that's our solute. It plugs into our numerator where we see moles in our formula. So 1.54 moles. All right. When you divide, you're going to see you need 2 sig figs in your answer because the 3.5 only has 2 sig figs. So your answer will be 0.44 molar or 0.44 moles per liter. Pause the video for a second and see if you can do this next one on your own. But for time's sake, I'm going to go ahead and proceed. So you can pause the video if you need to. This problem here wants us to find how many moles of hydrochloric acid are present in 0.80 liters of a 0.5 molar solution. So they've given us a little bit different information here, but we still will be using the same formula. Molarity is equal to moles per liter. We do know the volume, so we're going to plug that in to the denominator again. 0.80 liters. They want us to find how many moles. So they're wanting us to find X. This is our number of moles. And they gave us the molarity. Notice here, this number, we'll plug in here. The capital M is molarity. We're going to plug that in here. So 0.50 molar, or moles per liter. So to solve for X, you're going to cross multiply here. So that'll give you X is equal to 0.50 mole per liter times 0.80 liters. Notice here your liters cancel, and that leaves you with moles of HCl. So for this one, we get for our answer 0.40 moles. Now, oftentimes they might ask you to go ahead and find the mass of your hydrochloric acid. So just for practice, even though this problem didn't ask us to do so, if they want us to go to mass, remember that's just a one-step conversion. Where you would use your molar mass again of HCl. The molar mass of HCl is going to be 1.01 plus 35.45, which is 36.46 grams per mole. That lets your moles cancel out, and that would give you, to two significant figures, 14.5, which rounds to 15 grams of HCl. Now again, this problem did not ask for the mass, but this was just sort of an aside here. What if they wanted you to go to grams? So you take your moles and convert it to grams. All right, so that is molarity. The next video lesson will be on molality.